What is the washer method? And why is it always next to the disk method? Well, when you take a rectangle and rotate it around some kind of axis, it forms a circular disk. Pi r squared times the thickness or times the height, however you want to look at it. The washer method is going to be more like this. It's a disk with a hole in it. It looks like a donut or a bagel. And it's really easy to find too, because it's just the same as one big disk with another smaller disk cut out. So the formula for finding the volume of something with the washer method really just means find the volume of the bigger disk and subtract the volume of the smaller disk. It's going to go something like this. And once again, it comes down to, can you find the proper radius? So look at part A. We're taking that region, and it's bounded by F and G. We're going to take that region and rotate around the x-axis. So when we're rotating around the x-axis, we have a small radius. I'm going to say the one from G down to that axis of rotation is going to be a lowercase r to represent the smaller radius. And capital R from the F function down is going to be your larger radius. So you just have to determine what each radius would be. If you said it was the actual functions themselves, you are correct. Please note I haven't actually put an equation in for f or g, but I just use the function term f and g there. Also, there is one important thing to note. When you're doing the washer method, this idea is not correct. That would be the distance between them squared, but really you need to take the volume of the entire large washer minus the volume of the entire small washer to actually get it. Never try and do that long or shortcut version. It is incorrect and it won't help you. So how does this change if my axis of symmetry changes? We know that the radiuses are not going to be the same. What happens at that point? Well, it turns out when we change where that axis of symmetry is, like y equals -2, that elongates both radii, both the one from F and the one from G. And to get the length of those, remember, to find those lengths, just take the top part minus the bottom. In other words, the top function minus a -2. And when you actually subtract a -2, that makes it +2. So that would be the equation for B. And then C, all of a sudden we're looking at an axis of symmetry that is above. This will really change our functions a bit. You can now see the axis up there in orange at y equals 7, and you realize it is above, so think about how that would affect the radii. Do you see how the big radius is actually the one going from the axis to the G function now? Because G is actually farther away from that axis of symmetry. When it rotates around y equals 7, it will be the larger disk. So, how do you get the length of those radii? You're still going to take the top part minus the bottom. In other words, 7 minus the G function and 7 minus the F function to find those. That would be how you set up that problem. Now, sometimes these things don't want to focus, and that's problematic, because it should be focusing, and yet it's not. Wow, that's not good. Well, due to camera malfunctions, I think I'm going to end this one and put a 1-minute video on separately.